Greetings everyone. I'd like you to realize that as you're going through this video, you can pause me at any time if I'm going too fast or if you want to stop and copy things. Sometimes that's much more strategic to pause so you're not writing as you're listening, okay? So what I'd like you to do is turn to page 80 in your textbook in Meyer. So again, if you need to go get your textbook, just put this on pause and come back. I'll still be here. Okay. We know that statistical significance is primarily a statistical statement that we generate by using inferential statistics. You don't have to know how to do a t-test or a chi-square, but those are some of the statistical equations that help us produce a statement of statistical significance. However, on page 80, Myers also wants you to know that there are some aspects of descriptive statistics that can help us as we're trying to analyze statistical significance. They, in and of themselves, they are not enough, but they do offer some clues to data. The second thing I always want you to remember is that when we're dealing with statistics in our class, we're always dealing with the experimental group and the control group, right? The comparison of the data between those two groups. All right, now, what are some of the factors? If we've done random selection, we've done random assignment, and we have controlled for the best of our ability for confounding variables, there's two things that can influence the outcome of our results in an experiment. And that's obviously the independent variable or chance. You can also call chance natural variation. Okay, so those are the two things. Obviously, we want this to be the cause of our dependent variable, the outcome variable. But we know that chance will always play a role in our results. So the job we want to do is try to measure chance. So remember, statistical significance, I want you to think of it like a weather forecast, right? It's always about probability. It's about the probability of chance and that role that chance played in your experiment. So for us, we want it to be 5% or less. It can never be 0 for something to be statistically significant. If it's more than 5%, then our results are not statistically significant. Okay. So I want you to do this. Take some time. Read these two questions and see if you can answer them. The answer is going to be on the next slide. So if after our statistical analysis we claim that the findings in our experiment are statistically significant, what does that mean? All right? Or what does it mean that we found a significant difference in our research? Sometimes you'll see it written that way. So obviously I really want you to try to write something down. Pause me, write an answer down, and then we can come back. All right, welcome back. So here's the answer to that question, right? Right here. So basically, if we're saying, if we do a t-test and we find out that the p-value is 5% or less, right? This is basically referring to the differences in our data sets. Remember, the experimental group and the control group, right? That those differences are larger than chance variation would predict, meaning that it is very likely that chance played a 5% or less role in our results. Okay? Now, if you get a p-value that's even less than 5%, let's say that's 3% or less, so the p-value is less than 3%, right? This is what we're saying. So again, I want you to read this to yourself, and I'm trying to give you different ways of understanding what we mean by this, this, and this, right? So I should say this. Okay? That's what we're trying to give you, different ways to understand it and comprehend this material. So again, I'm not going to just read it to you. You should go through, pause, and read through these. Okay. So now where does descriptive statistics come into play? This is on page 80. This was some really important stuff, and I tried to talk about it today in class, and I wasn't happy with the job I did with it. So I'd just like to go over this again with you now. So this is what reliability means in the context of an experiment. And this is the goal. Basically, if our results are statistically significant, we feel much more comfortable and safer to generalize our results to our broader population, right? Because remember, we have a sample of the population that we're experimenting on, right? So the goal always is to apply. So if you want, this is just another word for applying, right? We want to apply those results to the broader population. Statistical significance allows us to do that. However, when we're looking at something like this, right? This again is such a small sample size. It's just doing it. You would have many more data points on here. So again, please realize this is just a simplified example. But whenever we're doing a control, putting together the data for a control group and an experimental group, we're going to use measures of central tendency and measures of variation. Remember the world of descriptive stats to figure out the mean of each group, and we want to figure out the standard deviation in each group. Myers goes through this. These serve as clues to help you figure out if the data is going to be statistically significant. I want to say this again. They serve as clues, but in and of themselves, they are not enough. You still would have to do a t-test or a chi-square to figure out the p-value. However, by looking at this data, there are certain patterns within the data that are more correlated with statistical significance when we're doing descriptive statistics. So here they are. This is just common sense. We want the difference between the two groups, averages, their means, to be large. Okay? We want them to be different. We obviously want to use, which I didn't in my example, large representative samples. Thirdly, this is really important. We want the standard deviations within both groups, experimental and control, to be on the smaller side. Okay? So again, we want them to be smaller than larger, because if the smaller they are, the more reliable the mean is. All right? So the smaller the standard deviation, the more reliable the mean. And again, we'd like to see a difference between the means. Okay? But again, that in and of itself is not enough to tell us that that the results are statistically significant. They just serve as clues, so to speak, okay, in trying to figure out if things are statistically significant. So that's page 80. I'm hoping that helped to clarify what he's trying to do on page 80 with reliability and statistical significance.